online and offline can be taken online all over the India, that right. And so far we have covered this basic numerics, that is number system. This all number system. The 22 questions will come from this area, and we will do now revision. Okay, so whatever we have done so far, we'll do a revision now. Wherever missed out, we can give, right. And see now, wherever you did not understand, let me know. That is, I will try to give more number of examples. Fine. Now you can see that natural numbers. Natural numbers. Natural numbers, we know. Natural numbers, what is the definition of, simple definition of natural numbers? Counting numbers. Like 1, 2, 3, 4, 5, 6, 7, 8, like, and so on. What is the largest natural number? It's infinite. That's right. And what is the smallest natural number? 1. That's right. And now you can see the consecutive natural number. These are the terminology which is being used in the questions. Right. Consecutive natural. Consecutive means what? Continue, without any break. What is a consecutive natural number? 1, 2, 3, 4, 5, 6. Even if you start from 10, 11, 12, 13, 14. If you start from 100, 100, 101, 102, and so on. Right. That is consecutive natural numbers. And consecutive odd numbers. So odd numbers are what? 1, 3, 5, 7, 9. Right. That is a consecutive odd numbers. 1, 3, 5, 7, or 11, 13, 15, 17, 19, 21, and so on. Consecutive even numbers. Even numbers are what? Which is divisible by 2. In other words, leaving remainder is 0. Like 2, 4, 6, 8. This is the consecutive natural numbers. Even numbers, that is. Even you can start from 78. If you say starting number is 78, 80, 82, 84, 86, 88, and so on. Right. And first consecutive natural numbers. First consecutive natural numbers. First consecutive natural. First means what? Starting from 1, 2, 3, 4. Like that. And multiples of natural numbers. Multiples of natural. Like a table. See, for example, multiples of 3. Multiples of 3 is what? 3, 6, 9, 12, and so on. So multiples of 7. 7, 14, 21, 28, and so on. So 11. Multiples of 11. 11, 22, 33, 44, and so on, like that. Okay, ellipse, we call it the ellipse, like that. Multiples of natural numbers. And sum and average of consecutive numbers. This is essential. Sum and average of consecutive numbers. So average is equals to the middle term in a consecutive number. So you can see, say for example, like 1, 2, 3, 1, 2, 3. And see, there are 3 numbers are there. What is the average of numbers? Middle number, this is middle term, is equals to average, like that. If you see 1 plus 2 plus 3 means what? 6. 6 by 3. So 2. 2 is the middle term. It's like that. Any number you can take of your choice. For example, 10, 11, and 12. What is the average? Middle term is the average. Middle term is the average. For example, you can see 10 plus 11 plus 12. It means what? 10 plus 11, 21, 23, 33. 33 by 3 is 11 is the average. For any take, you can like that. Even for example, you can see 5, 6, 7, 8, 9. You can see. What is the average? Middle term is the average. It's like that. So that is the thing. Sum. When you want to know the sum, what happens? No, average into number of observations. Number of observations. Best always you keep an average. So multiplied by the number of observations. That is the sum and average of the consecutive numbers. Whether it is odd numbers, whether it is a consecutive natural numbers, is even numbers, or multiples of numbers also. Even multiples of numbers, if we take, say for example, 3, 6, 9, 12, and 15. So what is the average? You can say 3 plus 15. First number from the beginning and first from the last. 3 plus 15 is what? 18. So 18 by 2 you will get 9. So 9 is a middle term, 9 is the average. It's like that. For any such numbers you can do. Even from, we can start from the somewhere like let us say the multiples of 3 only you can say, like 12, 15 and 18. What is the sum of 12 and 18? 12 plus 18 is what? 30. So 30 plus 2 is a 15. See, the 15 is there. It's a middle term average. Like that it will come. Okay. And n into n plus 1 by 2. N into n plus 1 by 2 is always to know the sum of the first natural number, first consecutive natural numbers. That is a thing, right? And face value, place value, local value. For example, if we say what is the face value of like that in a number 3, 1, 6, 7, what is the face value of any digit is itself only. Okay, place value differs. Place value is one local value. For example, what is the local value of 7? 7 only. And place value is also 7. Place value is also 7. 6. What is the face value of 6 is 6 only. Place value is what? 60. Like that. And what is the face value of 1? 1 only. What is the place value? 100. It is the hundreds place. Like 3. What is the face value of 3? 3 only. Place value of 3 is what? Thousands, that is. Okay. That's 1,000. 3,000. That is a thing. And that is a face value, place value local. And relationship between mean and middle term. Mean, nothing but mean is what? Is a middle term only. Mean is what? Middle term only, like that. Okay, right. Sometimes that word is being used. And see, now we can see.
Yeah.
Right. Now we can see number of digit numbers. Like what is the digit numbers? You can see sum of the digits of the number and sum and average of n digit numbers. N digit number. N is a 1 digit. 2 numbers, 2 digit numbers, 2 digit numbers, like that. 1 digit numbers. 2 digit numbers, 3 digit numbers, like that. Okay, 1 digit number. 1 digit numbers are, how many are there? 1 to 9. There are 9. 2 digit numbers. How many 2 digit numbers are there? What is the logic you need to apply? You can see the largest 2 digit number is 99. 99 minus 1 digit number. Because why like 90? Because 2 digit number starts from 10 onwards. Up to 9 we don't take. That's why. That's a very simple one. And how many 3 digit numbers are there? Largest 3 digit number is what? 999 minus, we are taking up to 99 should be subtracted from this 99. It means 900. So 9, 90, 900 it will go something like 3 digit number. If it's a 4 digit numbers are how many? 4 digit numbers are 9,000 based on this 4 digit number. Okay, like that. What is the 5 digit numbers are how many? 5 digit numbers are 90. It's like, okay, right. So how many 9 digit numbers are there? How many 9 digit numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Remaining all are zeros. 9. Whatever it is there, you can see that is okay. See, this is how you can say. Even here also, if a sum and average if we take, what is the average of the 2 digit numbers? What is the average of the 2 digit number? Average of the 2 digit number, how do you take? Because 2 digit numbers it will come 10, 11, 12 consecutive numbers again. What is the first 10 plus 99 by 2? You will get the average. You will get the average. And what is the sum means what? 109 by 2. If you do 109 by 2, you get the average multiplied by how many numbers are there? You will get the sum. For how many digits are there? In 2-digit numbers,
90.
numbers are 90. 2-digit numbers are 90. How many digits? 2-digit numbers, no, this is 90 are 2-digit numbers. How many digits are there? 90 into, in 2-digit numbers we smart, into 2, 180. Digit means individual. Okay. Number may be 1-digit number, 2-digit number, 3-digit numbers. How many digits will see in 3-digit numbers? How many digits will appear in 3-digit numbers? How many? 3-digit number into 3, 2700, like that. So that is how we can do. This is what's individual. Number means 1-digit number, 2-digit number, 3-digit numbers. So like that we can take. Counting of digits in the natural numbers. That's what counting of digits in natural numbers. Yes, next you can take yes, next it comes to right. Now you can see the finding prime numbers. Prime numbers, what is the definition of prime numbers? A number which can be divisible by two distinct factors, that is by itself and one. So the reason one cannot be a prime number. One, what happens now, one can be divisible by itself and one. One and one, two factors are the same. It's not a distinct factors. So one cannot be a prime number. That's the definition. And prime numbers starts from where? 2, 3, 5, 7, 11, 13. Okay. How many prime numbers are there in the first 100 natural numbers? 25. How many even numbers, even prime numbers are in the number system? 1. That is 2. Except 2, every prime number is odd number. Okay. Right. That is a thing. Prime numbers. Factors. Factors is what? Factor is what? A divisor. Factor. Factor. Factor means what? A divisor. A divisor. Which divides the number completely. Living remainder 0. That is called a factor. So right, examples you can take. For example, 7 is a number which can be divisible by 1. 1 7s are 7, remainder is 0, so 1 is a factor. And if you take 7 by 2, it means 2 3s are 6, remainder 1, so 2 is not a factor. Next you can say 7 3 2s are 6, 1, there is a remainder, 3 is not the factor for 7. And 4, like 4 1s are 4, remainder is there, so 4 is not the factor for 7. And 5 1s are 5, 7 this is 2, 5 is not the factor for 7. Like 7 by 6, now remainder 6 is not the factor for 7. And 7 by 7 is a factor for 7, itself is a factor. So for 7, factors are what? 1 and 7. This is the one thing. And again, you can see for finding factors for any number, like finding factor finding factors is product of product of product of two numbers also, that is easy. For example, 7 you can take, if you start 1 into 7, product of 1 and 7. Okay, right. And again, if you take, for example, how we can write, if you write like that, it takes long time. So 1 into 8, 2 into 4, 3 into, no, 4 into 2, again repeat starts. It means how many factors for 8? There are 4 factors. For example, if you say like 18, what are the factors for 18? 1 and 8, 2 and 9, 3 and 6, 4 no, 5 no, 6 again repetition will start. So there are 6 factors. Otherwise you will have to write like this. It takes a lot of time. 1 by itself and 1, 2 is even number, 2, 3, 4, 5, 6, 7, 8, 9. It takes long time. It's like a longer time. This is a product of pair factors is the easiest method, that is right. So now we can see right. So and factors, factorization is applicable for whom? Composite numbers. For any composite number is equal to prime factorization. Composite number is equal to prime factorization. Prime factorization is applicable only for the composite numbers, because prime numbers, what happens is by itself and one are the factors. There is no prime factorization. Next, for example, 18. Let us take 18. What are the factors for 18? Then you have to do LCM. What is the LCM of 18? Right, 2 9s, 3, 3. Right. It means 2 into 3 square. 2 into 3 square is the prime factorization, like that. And see, like 75. What is a prime factorization for 75? You can do the LCM. LCM you can do. It means 75, 325. Okay, right. Right. It means no. 3 2s are 6, 1 5, 3 5s are 15. Like again you can say 5 also you can take like that. 5, 15. Okay. What I am doing, it is not, that is not the correct one. Like that I should do. LCM I take. See, 5, 15, 5, 3, 5 into 5 into 3, 5 into 3 is like that. Or you can take 5 square into the either factorization. This is a prime factorization, right? Prime factors. What are the prime factors? Prime numbers. Because what are the prime factors in the 75? 5 and 3. All that is the thing, that is okay. Yes, now we can see. Now you can see prime factorization is more common factors. What are the common factors you can see? If there are two numbers, if there are more than two numbers, you can see the common factors. For example, you can see common factor. What are the common factors you can see? For example, 4 and 4 and 6. What are the common factors for 4 and 6? 4 factors are what? This is by itself 1 and 2. These are the factors. For 6 what happens now? By itself 1, 2 and 3 is all. What are the common factors? 1 is a common factor. 1 is a common factor. 2 is a common factor. And 3 we can't see here 4. So 1 and 2 are the common factors. So common factors are 1 and 2. It's like that. Very simple that is. Okay. Right. And common total number of factors. Total number of factors for any number you can say. What are the total number of factors for 6? 4 factors. What is the total number of factors for 4? There are 3 factors. That's all. And total number of factors, sum of factors. Sum of factors means you have to put up the total for factor. What is the sum of factors for 6? Sum of factors for 6. It means 1 plus 6 plus 2 plus 3. 6, 9, 12 is a sum of factors. Okay. And even factors, odd factors we can see after some time, that is. Okay. Let us not get into the thing, that is. Right. And composite numbers. Composite number factors of factorization, already we learnt it now. Because I just put like that because see, you should not forget anywhere like that. Sometimes if you forget in the item number 1 or 2, at least you can recollect memory back by saying this also. That's all I put like, intentionally I put like that. Okay. And a composite number factors factorization. Factorization is total value. Factors are what? Any number of factors. You can say prime factors, you can see that. And LHS equal to RHS. It means composite number is equal to the prime factorization. That is say LHS equal to RHS. And equal to the value of prime factor. Again I put it like that. Right. Next, prime number related. See, and prime number related. Co-primes. What is the definition of co-primes? Co-primes definition. This is very important for us. Even division method also we need this. The both number. Co means 2. Co means 2. Of course. 2 numbers which should be divisible by only 1 or otherwise SCF must be 1 between the numbers. For example, 3 and 4. 3 and 4 is a co-prime numbers. 3 and 4 can be divisible by only 1. So 3 and 4 is a co-prime numbers. 4 and 7, one even number, one odd number is there, means naturally is a co-prime numbers. For example, you can take 15 and 19. And this is the co-prime series. Even 15 is not a prime number, but if you look at that number, it's prime numbers to each others. It's like that. So it's a co-prime numbers. And 15 and 21, you can see. 15 and 21. How do you check it out? 15 and 21. And we can see the sum of the digits divisible by 3 or not. Even multiples of 5. 15 is the multiples of 5. When some number is multiples of 5 and 21 is the multiples of 3. So definitely it's not co-prime numbers like that. And next, twin primes. What is twin primes?
Difference.
So, okay, if you talk about co-primes, if a number is to be divisible by 80, n is a natural number, divisible by 80, what is the rule you need to apply? N is a natural number which is divisible by 80, how it should be divisible by 80? What is required to be done? You need to know the co-primes. You need to know the co-primes. What are the co-primes of 80? What are the co-primes for 80? What are the co-primes for 80? When you want to know the co-primes for any number, you should start with the least number. You should start with the least number. So 1 you don't take, 2. If you for 2, what will happen? 2 into 40. What is the SCF? What is the SCF? 2. So this is not the co-primes. Divisibility method, we need this. We need this. Essentially we need this. Okay, both numbers are multiples of 2. So 2 is the SCF here. So it cannot be co-prime numbers. Yes, that both the numbers should be divisible only one and only. Then it is the co-prime numbers. Here 2 is the common divisor, highest divisor. 2 will divide 2, 2 will divide 20 because both are even numbers. Right. When both are even numbers, it cannot be a co-primes, that is. If we talk about 3 and no, it cannot be divisible by 3.
So 5 into 16.
5 into 16, wonderful. If we take 4 into 20, both are even numbers. Both numbers can be divisible by 4. So, no. Next to 5 into 16. These two numbers, even 16 is not a prime number, but if you look at this one, these two, if we compare the result between these two prime numbers to each others, both can be divisible by only 1. So 5 and 16, the number is to be divisible by 5 as well as 16. So what are the prime numbers for 80? 5 and 16 is a co-primes. It has to be divisible by 5 and 16. 5 and 16. So that is how we need to, this is the essential. Even we can do by 80 also, but that is not the thing. For exam point of view, question, based on the questions given, we need to know this is co-primes. Okay, yes, next, twin primes. What are the twin primes? Difference between two consecutive prime numbers is 2. Difference between two consecutive numbers is 2. Then it is known as twin primes. What are those? Give me some 4-5 examples. Twin primes. 3 and 5 is a pair. 5 and 7. No. 11 and 13, etc. Okay. How many twin primes are possible in the first 100 natural numbers? 8. Okay. We have already checked it. So that you should make a point of it. Prime triplets. What are the prime triplets? Triplets means what? 3. Prime triplet means what? All 3 are prime numbers. The difference plus 4 and plus 6. Alva? Okay. So first number plus 4 and first number plus 6, or plus number 2 or plus 4, plus 2 plus 4 or plus 4 plus 2. Okay. What is a, give me 1 or 2 triplets.
5, 7, 11.
5, 7, 11, yes. Another one more.
11, 13, 15.
11, 13, 17. 11, 13, 17. Right. Fine. How many prime triplets are possible in the first 100 natural numbers?
8.
8. That's more than that. Okay. We don't need that much like that. Right. Now next it comes to the integer. Integer is, you have to see the only number line. Number line. Integer, how many types of integers are there?
Negative and positive.
Positive, negative, integer. Integer, positive integers, negative. 0 is the integer.
Yes.
Okay, 0 is neither positive integer nor negative integer. What are the positive integers? Plus 1, plus 2, plus 3, plus 4 and so on. What are the negative integers? Minus 1, minus 2, minus 3, minus 4 and so on. Right. And you can say squaring a number. And squaring a number, how to do the numbers? Summing of consecutive numbers. Okay. So, for example, 11 square, 10 square plus 10 plus 11. Okay, that's summing of the number. For 21 square, 20 square plus 20 plus 21. 31 square, 30 square plus 30 plus 31. 91 square, 90 square plus 90 plus 91. If we come reverse way, 9 square, we know the 9 square is 81. But what is 9 square? Yes, 10 square minus 10 plus minus. Okay, that also is minus 10 minus 9. It's like that, both. That's all. If you come reverse way, you have to put minus minus. Right. And A plus B whole square pattern. That already we learnt in A plus B. You got 21 can be written as 20 plus 1. 35 square be written as 30 plus 5 square, whole square. A square plus 2AB plus B square. We have to do that is right. Arithmetic process. What is arithmetic process? We can see because 21 square can be written as 21 into 20 plus 1 is like that. That also you can. That's what arithmetic process. Quick multiplication process. This is the Vedic mathematics formula. That is again A plus B whole square only, but we come from right to left. Right to left we come. Now properties of 2, 3. Right. Now we can see now you can see what are the properties of 2. What are the properties of 2? Properties of 2. Give me some 4 or 5 properties of 2. Uniqueness of numbers that 2 is the smallest prime number. 2 is the smallest prime number. 2 is the only even prime number. Only, because that's we have to take only even prime number. Yes. 2 is the 2 is the second natural number. Okay. 2 is the second natural number. Next.
Every even number can be divisible by 2.
Every even number 2 is the number which divides every even number. Okay, you are putting wrong, that is. Or every even number is divisible by 2. 2 divides every even natural number. Right, yes. Anything like that? One more is there, more important that. Exponent values, doubles. For example, 2 to the power of 1 means 2, right? When 2 to the power of 2, that becomes 4, doubling the value. Like 2 to the power of 3, 4, 8, doubling it just. 2 to the power of 4, it means 16, it just gets 2 to the power of 5 and 30 and so on. This is possible only for 2, not for any other number. These are the areas questions are asked. Okay, right. And next, uniqueness of 3. What is the uniqueness of 3? Uniqueness of 3. What you can do? Uniqueness of 3.
Smallest odd prime.
The smallest odd prime number. The smallest odd prime number, like that. Yes, 3 is the sum of first 2 natural numbers. 3 is the sum of first 2 natural numbers. 1 plus 2. First 2 natural numbers, 1 plus 2 is equals to 3. It's like that. Next. Yes, next one. Okay. Right. 7. So 7 is the another prime number. Okay. You can take 7 is another prime number. Okay. We don't find much uniqueness further. We have to find out. 9. 9, you can see there are many things of 9. No? 7 I have to take out from the list. 9. What is uniqueness of 9? You can take uniqueness of 9.
2 digit.
Yeah, because see that is 9. See, there are many things can be said for 9 like that. Even I mentioned after that also. What is that is
Squaring.
Squaring. What you can say, 9 is a multiples of 3 or 9 is equal to 3 square. That's okay. That everyone knows about it. What is the uniqueness of 9? And a 2-digit number, interchanging the digits and subtracting, the difference is always divisible by 9. Say for example, like 81 minus reversing the digits and subtracting. This is the multiples of 9 into x. 9 into x. The result is always divisible by or multiples of 9. You can say like that. That also you can see. That is one thing. Another thing is you can say that is 9. Sum of the digits subtracting from the original number the result is always divisible 9. Say for example 1, 2, 3 is a 3-digit number, minus 1 plus 2 plus 3. So 1, 2, 3 minus 6, 1, 1, 7 is always divisible by 9. It's like that. It's like that. 1 plus 1, 2, 2 plus 7 is 9. It's like that. Right, that is the thing. Okay. Next, you can take, right now we can see, sometimes even you can see that is also 81, 81 minus 18, then fine. You have to see that is, what is the difference between 8 and 1? 7. 7 into 9 is like that we can take. Difference between the digits. Interchanging and reversing it, always you can say difference between the digits like that. Right. 11. 11 comes what happens? Same 2-digit. 2-digit number 81 plus 18, 9 is always divisible by 11. You can take 11. That is the thing. But how do you write for this equation like this for additions? You can take additions, you can take, how do you write like that? 2-digit number, how do you write in the equation wise? Equation, if you write xy is a 2-digit number, xy is a 2-digit number. Xy is a 2-digit. If you write xy, what will happen? It becomes, how do we read? We read like x into y. We read like x into y. But how to write this is 10x plus y, like that. 10x plus y. So, and reversing the digits if we take like that. How do you write down? See, 10x plus y. Okay. And minus, reversing the digit, 10y plus x. Always we write like that. Sometimes what happens now, we may go wrong also. Xy is 2-digit, we say that we think like x into y. There is a possibility of going wrong side like that. Okay? Yes. When you wanted to mention in tens place and units place, we are supposed to write like this only. Okay? Yes. Now we can see what is the next one. 13. Okay, 13 you don't take like that. Complication is there. Let us not take. 99. What 99? 99 you can see what are the divisibility rule we apply. Reversing the reverse side you have to do. So you can take any number 3 digits A, B, C, like A, B, C, like A, B, C. This is difference always 7, 11 and 99 is same rule like that. Like that. Okay, now we can say 99. What are the co-primes for 99? 9 and 11. Yes, that's what I want. Okay, very nice. You always start with the least numbers. 9 and 11. And 101, 101, 1001, so on it is there. It means 101. What happens now? A 2-digit number. Okay, a 2-digit number. If you take a 2-digit number, xy is a 2-digit number. Xy is a 2-digit number multiplied by 101, repeating the 2-digit number xy. Isn't it? A 2-digit number is xy multiplied by 101. That result is repeating the 2-digit number. So, like AB is a 2-digit number multiplied by 101, repeating AB and AB. In the sense, for example, 12 into 101 by 12 and 12 is the answer. Okay. And 79 multiplied by 101, 79 and 79 is like that. 83 into 101, 83 is like this. Okay. And same way it will continue like that. Even for 1001, and you can see 1001, ABC is a 3-digit number. ABC is a 3-digit number multiplied by 1001, your result will be ABC, ABC, like that. 3-digit number gets repeated. Say for example, 123 into 1001, result is 123, 123, is like that. And it goes on like that. It goes on like that. And 4-digit number, if you take 4-digit number, that's why, and so on you can write. 1, 2, 3, 4 multiplied by 1, 3, 0, 1. It means 1, 2, 3, 4, 1, 2, 3, 4, like that. So that is a thing. It's like that. That 1001. Again, 1001, there is a unique property. 1001, you have to see that is. 1001 unique property is what? It is a product of 7 into 11 into 13. Very essential. These are the areas questions are asked. These are the areas questions are asked. 1001 is referred to as product of 7 into 11 into 13. It means 3. What is the relation can be developed here for 7, 11, 13?
Right.
Prime numbers, fine. Another logical thinking. So we have attended so many classes, you must say some logical thinking.
Triplets.
Fantastic. It's a triplet. It's a prime triplet. That is what this a prime triplet this is. Okay, plus 4, plus 2. Or another point. Another point. What is another logical thinking? It's a prime triplet. Yes. Next. It's a consecutive 3 prime numbers. Consecutive 3 prime numbers. That's like that. Okay. Right. That's how they look at the question. Okay. Really. See, that is now we can see and so on. Right. Yes. What are the other things now we can see? Yes. Now sum of n terms of odd numbers. Sum of n terms of odd number. Again, see. Now we can see result. Now let's talk about now you can see this is sum of n terms of odd numbers. Sum of n terms of odd numbers. N terms, whether 1 term, 2 term, 3 term, 4 terms, like that. Okay, it's a talk is about odd terms. Sum is of n terms of odd numbers. See that. Questions are asked here only. Okay, now what happens odd number? See, it's a it's a odd number. Okay, I think we don't say anything here. Even like 1 plus 1, there are sum of n terms of odd numbers. What will happen here? 2. Sum of 2 odd terms is even number. Okay, 1 plus 1 plus 1. What will happen? 3. Sum of 3 odd numbers is odd number. 1 plus 1 plus 1 plus 1 is what? 4. Sum of 4 odd terms is even number. See, sum of 2 odd terms is even. Sum of 4 odd terms is even. Now we can take 1 plus 1 plus 1 plus 1 plus 1, 5. The 5 terms. And 1 plus 1 plus 1 plus 1 plus 1 plus 1, 3, 4. What? 6. See, there are 6 odd. This small thing you can check it out. Small things you can check it out. This is. You may forget. Naturally, I understand this. You may not remember, but you can check it out within 2-3 seconds time. So, sum of odd number of terms is odd number. Result is odd number. Sum of even terms of odd numbers is even number. That's what you get. Okay. Sum of n terms of even numbers. Like 2 plus 2, 4. 2 plus 2 plus 2 plus 2, 6. Okay, 2 plus 2 plus 2, 4 times, again even only. N number of sum of n number of even terms is always even. It's like that. And the product now, product of n terms of odd numbers. Product. Okay, even I think one more I have written here. Subtraction also I should write that. Okay, product of n terms of odd numbers. Let us say 1 into 1 only. 1 into 1 into 1, 1 only. Okay, for 1 everything 1 comes. Everybody knows this. Okay, that's right. Like 1 into 3, 3. 1 into 3 into 5, 15, odd number. 1 into 3 into 5 into 7. When the 5 comes means all odd number. Product of n number of odd terms is odd number only. The product of n terms of even numbers are 2 into 4, 8. 2 into 4, 8. 2 into 4 into 6. Like that. So that is even number. So that is a one thing. And even subtraction also you can do, that is odd number plus odd number minus odd number. Even, like that you can say that is odd number plus odd number, even number. Odd number minus odd number, even number. It's like that. Be very careful, that is. But these are very scoring area. Actually 2.5 marks. Very big scoring. Okay, like that. And now I can see more properties of that is. Right. A 3-digit number found by repeating 1-digit number thrice is always divisible by 111. What do you understand by reading this group of words? A 3-digit number, let us write 3-digit number, okay. Repeating a 1-digit number thrice, it means 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4 and so on. Okay, always divisible by 111. Always divisible. I did not see the last year paper properly actually. There was a question last year like this. Okay, always divisible by 111, but also 111 is the product of 3 and 37. 111 is a product of 3 and is a fixed property. If the number is divisible by 111, it also divisible by 3 as well as 37. It's like that. Okay. And sometimes the question may arise like, what is the sum of the factors of 111? So far it is not asked. It may be. I do not know. How do you write that time? What is the sum of the factors of 111? 111 factors are by itself 1 and 3, 37 you have to put.
150.
Whatever it comes like that. If you want to create some confusion, what is the sum of the digits of the resultant number of the sum of the factors of 111? By reading itself we go panic. So it's like that. Okay, right. Anybody can say like that. So that's what I can say and think. Now such numbers are also divisible by 3 and 37. It's like that. And 4-digit number. A 4-digit number found by repeating a 2-digit number always divisible by 101. When you are multiplied by 101, it can be divisible by 101. That's all. See, for example, you can take 31 into 101. What will happen? 31, 31. Here the what says that is reverse again. A 4-digit number found by repeating a 2-digit number. 31. Repeating a 2-digit number always divisible by 101. When you are doing a multiplication order, you should also be knowing coming back. So that is the thing. It means you can take like that 31 by it means what? 31 you can take. So that is the thing. Okay. Now the number 0 is surrounded by the same 2-digit number. Number 0 is surrounded by same digit on both sides. It is such 5 digit always divisible by 101 again. See, like 25 into 101, what will happen? You can see. Oh, that is okay, no? And 25, 0, 25 is always divisible by 1001, he says that. Okay, already 1001. Not only 1001 is a product of 7, 11, 13. It's a product of prime triplets. So it also can be divisible by 7. Even you can say 7 into 11 into 13. See, 7 ones are 7, 3 remainder 30, 28, 3, clear. 11, 10, 10 gets over, 13, 13, 7, 91, 91, clear. See that. Okay, yes, that is a thing. Right now we can see
Sir, the touch. ಅಲ್ಲಿ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳಿ.
ಇದು now we can see. Now since the 1001 is a product of 7, 11, 13, right. Next a 6-digit number. A 6-digit number found by repeating a 3-digit number always divisible by 1001. Say because what is a 1, 2, 3, 1, 2, 3 always divisible by 1001 like this. That is the thing. Okay, and we learnt it. 1, 2, 3 multiplied by 1001 is equal to 1, 2, 3 and 1, 2, 3. Right. Now next, sum of the digits of the natural number is subtracted from the number itself. The resulting number is always divisible by 9. We checked it already. Uniqueness of 9 like that. The difference of a number consisting of 2 digits, okay, 2 digits, and the number found by interchanging the digits always divisible by 9. We checked it already, no? Uniqueness of numbers like that. Sum of the 2-digit numbers, the number found by interchanging the digits always divisible by 11. Okay. Digits of a 2-digit number are reversed. Difference between the original number and the new number is always divisible by 9. Same thing, okay. Digits of a 3-digit number are reversed. Difference between the original number, new number is always divisible by 99. Okay. Difference. Do we need examples now here? Not necessary. Difference between the square of a 2-digit number, the square of a number found by interchanging the digits always divisible by 99. Okay. Okay. Now we can see this is done. Now it comes to Fermat's little theorem. Anyway, theorem you don't remember it everything. And P is a prime number, where P is a, this is like that. Okay. It's a always x into prime number. That's what you can say that is. But let us take the, like you can take n. N is a natural number, P is a prime number. This is a fixed, now n is a, let us take n is a natural number, 2. What is a prime number? Let us take prime number. Minus natural number, 2. It means 4 minus 2 is 2. It is a product of prime number. It's like that. And you can take 2, prime number 3, minus 2. 8 minus 2 is 6. This will qualify. And 2 to the power of 5 minus 2. It means 2 to the power of 5 is 16, 32. 32 minus 2 is 30. 30 is the product of like 5. It goes on like that. 3, 2 minus 3, 9 minus 3 is 6. 6 is a product of prime number. It's like that. That is the theorem. That is. You have to write that properly. Even you have to write for 3, 4, 5, 6, 7 I think some practice is required for that is. Did you do that? Did you not do? You did do. Because we need to know. Otherwise, you go panic. But easily scoring area, these are areas. Looks funny, but scoring area. That is a thing. Right. Next, number of index numbers. Like, so one is logical thinking. What we do, like that. Number of two digit, number of one digit number. One digit numbers. One digit number. What is a formula? You can take 9 into 10 to the power of n minus 1 for finding the one digit numbers. Okay. Right. What is the formula? You can say 9 into 10 to the power of, how many one digit numbers we need? Let n can be 1 minus 1. Here 9 into 10 to the power of 0. 1 minus 1 is 0. Okay. Now 9 into 10 to the power of 0 is what? 1. So 9. Okay. This also should be known to us. Okay. If you want to know the two digit numbers, how do you write two digit numbers? 9 into 10 to the power of 2 minus 1. 9 into 10 to the power of 1. 9 into 10. So there are 90. Again, you should be knowing this. Even if you forget also no problem, but formula will apply. Write the formula. You have to write for all the 9 digits number. Okay. Right. Now we can see number types of numbers. Natural numbers, even numbers, whole numbers, prime numbers, composite numbers, rational numbers, irrational numbers. Right. Next, divisibility rule. Which number can be divisible by which number? If the number divisible by 1, we don't take, we don't consider. Divisible by 2, even numbers. Any even number is divisible by 2. Or what is the definition of that? The last digit of the number must be 0 or even. Right. Divisible by 3, sum of the digits. Divisible by 3, what is required? Sum of the digits must be divisible by 3. And 9, even sum of the digits must be divisible by 9. The whole number can be divisible by 9. 3 and 9 is the same rule. Okay. And 4, last two digits. For 2, last one digit. For 4, last two digits. Okay. For 8, last 3 digits. For 16, last 4 digits. For 32, last 5 digits. That's right. And you remember. Okay. And divisibility rule. Okay. And unit digit value. What is unit digit value? Only we calculate for unit digits like that. 1 into 2 into 3. For example, like 91 into 92 into 93. What is a unit digit value? What is unit digit? 1 into 2, 2 into 3 is 6, like that. For example, 6 factorial. What is a unit digit? For 6 factorial, what is a unit digit?
2 or 3.
6 into 5 into 4 into 3 into 2 into 1.
0.
0. 6 into 5,
6,
30, 0. 0 multiplied by any number is 0. It's like that. Okay. And what is unit digit in the multiples of odd numbers? 1 into 3 into 5 into 7 into 99.
0.
5.
5 is there.
5. 5.
0 happens only when one combination of 1 5 and 2 should be there, or one even number and one 5. All these odd numbers.
5.
0 will not come. So any number multiply, any odd number multiplied by 5, unit is at always is a 5. Okay, like that. See, that is a thing. Right. After that, for example, 3 to the power of 41. What is a unit digit? 3 to the power of 41. What is a unit digit? What is a unit digit in 3 to the power of 41? 3, no? How do you calculate? How did you do that?
4.
How much time did you take? So, recycling of number here, cyclicity of 3. How do you do that? I'll tell you, see how to do. Very second, with fraction of second. You are not here. Okay, right. Now you can see, for example, 2 to the power of 11. What is a unit digit in 2 to the power of 11? Then you can see what, see, we do not know, no? Right. And you have to, I will write here 2 to the power of 1, 2. 2 to the power of 2, 4. 2 to the power of 3, 8. 2 to the power of 4, 16. But we take 6. Okay. 2 to the power of 5, 32. Let us take 2. 2 to the power of 6, 4. 2 to the power of 7, 8. 2 to the power of 8, 6. It means what is your observation here? 2, 4, 8, 6. 2, 4, 8, 6. It gets repeated. How many terms a cycle? 4 terms a cycle. Then 2 to the power of 11, 11 by 4. What will happen? 2 to the power of 3. Then what is a 2 to the power of 4? 8. Unit value is 8. Unit digit is 8. It's like that.
So for everything is the same, sir?
Exact, yes.
For 3?
For 3 also, you have to write like that. But
6 1 side.
But this takes more time. This takes more time. Comparatively, what you can do, brilliant students, what they will do that, okay, you are writing like this, you want to know the number of terms like this takes more paper, space. What you can do, 2 to the power of 1, 2, 2 square, 4, 8, 16 and 2. When 2 comes now again repetition starts and 4 terms is a cycle. 4 terms is a cycle. Within small 1 inch space is enough. You don't write like this. Making understand, I write like this. Intelligently we should do like this. Okay, and see now 2 to the power of 25 into 3 to the power of 25 into 4 to the power of 25. What is a unit digit? What is a unit digit?
For 2 to the power 25, 25 divided by 4.
Divided by 4. You will have 2 to the power of 1. Remainder, whatever the remainder is a real power. And 3. Let us write 3, 9, 9 into 3, 27, 7 into 3, 21, 1 into 3, again 3 starts, 4 terms. It means 3 to the power of 1. Remainder will be 4, 25 divided by 4. And 4 to the power of 25, for 4 4 the 16, 6 into 4, 24 and 6. 2 terms is a cycle, 2 terms a cycle. You should say 2 terms a cycle. 25 is an odd number, divided by 2, remainder will be what? 1. It means 2 into 3 into 4. It means 2 into 3, 6, 6 into 4, 24. 4 is a unit digit. 4 is a unit digit.
Sir, for 2 to the power 25 you divide by 4, sir. For 3 to the power 25 you divide by 4. For 4 to the power 25 you divide by 2.
Because 2 times a cycle. Number of terms in a cycle is 2. So that. But the only thing is what you have to do that. See, for example, 2 to the power of 24 into what is unit digit in 2 to the power of 24 means this 24 divisible by 4, that becomes 2 to the power of 0. 0 means not actually 1, that is last term of the cycle here. Last term of the cycle. Last term, fourth term of the cycle. What is the fourth term for cycle? 6. So that is 6 is the real answer. But you cannot see like algebra. 2 to the power of 0 is means 1 means. It's like that. Should I write little more clarity? See, now we can see
Sir, now what was the answer for the before one, sir?
which one? 6. See, for example, 2 to the power of 4. What is a unit digit in 2 to the power of 4? 2 to 4. It means you write 2, 4, 8, 6. When you can see 2 to the power of, I will write 5. What is the remainder? 2 to the power of 1. 2 to the power of 6. What is the remainder? 2 to the power of 2. 2 to the power of 7. What is remainder? 2 to the power of 3. 2 to the power of 8. Remainder 0. Remainder will be 0. It means that is a last term you have to take. Last term. What is the remainder? Is a real power. When you say that remainder 2 to the power of 8, 4 term remainder will be 0. That is last term of the cycle. Last term of the cycle you can take 6. For any number. That's the only area where you need to be a little more careful. Okay, right. That is the thing. For 9, how many terms a cycle for 9? For 9. 9 is 81. 9 and 1. 2 terms a cycle. For 9, it's only 2 terms a cycle. You may get questions like that. 19 to the power of 19 and 21 to the power of 21, 33 to the power of 33. What is a unit digit? What is the unit digit? You take unit digit means here 9, 1, 3. 9 to the power of 19. What is the cyclicity of 9? 2 terms. 9 to the power of 1. And here 1 to the power of 21 only. Into 3 to the power of 33. 4 times a cycle. That is 3. It means 9 into 27. So unit digit is 7. It's like that. Let the number be any big number. Maybe 3-digit number, 4-digit number. You don't bother about that. They try to create funk, confusion, like that. They write like that. 555 to the power of 555. What is a unit digit? We go panic. The people who did not attend classes, who did not like that, that's a problem. So you take the 5. 5 to the power of 5. 5. Only 5 to the power of 1. 5. Only one time a cycle. 5. 6. Only one time a cycle. 1. 1 time cycle. There are 3 such numbers.
10.
10.
10 is a 0.
One term cycle.
One term is cycle.
5, 6 and 10 is 1.
One term is cycle. There is no 3 terms cycle here. There is a 1 term cycle, 2 term, 4 term cycle, 2 term cycle. 3 term cycle is not there. Of course, it's not a complicated one. This is very easier one. This is. Okay. Mentally also you can finish it. I told you mentally you can how can this like that. You don't write like this.
No.
Wasting your time. That is right. Yes. Next. Now we can see the unit digit values over. Remainder rule. What's the remainder rule? You can see that is remainder. If you divide such a number, what will be the one is you can say, for example, 3, 1, 0, 4, 6 divisible by 4. What is the remainder? What is the remainder? What is the rule of 4 divisible? The rule last 2 digits you have to take, isn't it?
0.
Last 2. 46 by 4. 46 by 4. 40, if there is 40, 40 is the multiples of 4 only. 44 is the multiples of 4 only. What is the remainder then? 2. 2 is the remainder. It's like that. Say for example, same thing, 1, 0, 3, 1, 2, 8 divisible by 8. What is the remainder?
3.
Last 3 digits you have to take. 2 to the power 2 square 2 cube like that. It means 8 ones are 8, 4 and 48. Yes, remainder is what? 0 like that.
So you should divide 128 by 8.
Yes. 128 by 8. Okay. And 103, 3 zeros divisible by 8. Yes, last 3 digits are 3 zeros is a multiples of 8. Because 1000 is the multiples of 8. It means this is equal to 1000. 1000 is a multiples of 8. It's like that. Remember that is a another remainder is there, that is what is the remainder means, say for example 1 into 2 into 3 into you can start taking like 1 into 3 into 5 into 7 into 9. 9 by, let us take 4. What would be the remainder rule? What would be the remainder rule? Let us check it out first. 1 into 3 is what? 3. 3 into 5, 15. 15 into 7, 105. 105 into 9. 105 into 9. 105 into 9. 945. 945. 945 divisible by 4. 945 divisible by 4. And definitely 1. Remainder will be 1. Okay. But if you apply like this, write 1 into 3, 3. 3 into 5, 15. 1 into 3, 3. 3 into 5, 15. 15 by 4, what is the remainder? 15 by 4.
3.
3. You can write 3 here. 3 into even 4. 7 by 4, how much remainder?
3.
3. Right. 9 by 4, remainder 1. 3 into 3 into 1. 9. But remainder should be much lesser than 4.
9 by 4.
9 by 4. Then comes 9 by 4. Remainder is what? 1. You can take like that. 1. So 1 you can take. It's like that 1. See, small 2 numbers I write like that. Like 5 into 9 divisible by 4. What is the remainder? What is the remainder? You can take 5 by 4. What is the remainder? 1. 9 by 4. Remainder?
1.
9 by 4.
1. 1. 4
Remainder I am asking.
1.
9 by 4, 1. So 1 into 1, remainder is 1. So 5 into 9, 45 by 4, 4 ones are 4, 0, 5, right, remainder is 1. This is the process again.
Sir, ಅದು ಮುಂಚೆ ಹೇಳಿದ್ರು ಅದು ಲಾಸ್ಟ್ 3 digits ತಗೋಬೇಕಲ್ಲ ಸರ್?
ಯಾವುದು? That is a divisibility rule.
ಅಲ್ಲ ಸರ್.
That is divisibility rule for 8.
ಅದನ್ನೇ ಹೇಳಿ.
Yeah, it's like that. Say, right, and see now we can see 19 into 11 into 13 divisible by like 15. What is the remainder? What is the remainder? If you take 19 by 15, what is the remainder? 19 by 15, 4. You write 4. 11 by 15, minus value it comes. Minus 4. It requires minus 4.
-2.
Minus 2, right. 4 into 4, 16. 16 into 2, 32. Plus into minus, minus. Minus into minus, plus. Is a plus value. Again this becomes 15. Remainder should be much lesser than 15. Then what happens remainder?
Again divided.
Yes, 2. You can check also, cross check. You can use the calculation, find it out. 19 into 11, how much? 19 into 11. Check the calculation. 19 into 11 into 13.
Sir, if they give
209.
Huh?
209.
209.
Sir, if they
209 by 15. 5, 9. Like 15 3s are 15 4s are 60. No, it's very big. 19 into 11 into 13.
2717.
2.
2717.
That's right. 2717. Divisible by 15. 15 ones are 15. Right. 15 eights are 121. 17, 15, 2. See the remainder.
Sir, negative element?
Negative, when negative comes, yes, negative should be subtracted from the divisor. Should be subtracted from the divisor.
So now if the answer is minus 32, then we have to subtract minus 32.
Minus 32, because anywhere 32 is higher than this number.
Hello, sir.
Divide.
Yes.
19 into 11.
I'll take one more example.
19 into 11.
Let us see that 11 into 13 into 17 by, let us take 15, okay?
That is 8 plus 12.
Plus ಬರುತ್ತೆ.
ಬರೀ 11 into 13 ಮಾಡಿ ಸರ್. ಅಲ್ಲ 13 into 17 ಮಾಡಿ ಸರ್. Thirteen into 17 by 15.
huh?
By 15.
By 15, right. Means this is the minus 2, okay?
Plus.
Here plus 2. It means 2 into 2, 4, minus into plus, minus value. Okay. 15 minus 4, so 11 can be the thing. Should be subtracted from the divisor.
Then remainder.
Remainder is 11.
11.
You can take 13 into 7, how much value? 13 into 7. 13 7s are 91. 13 221, right? Right, divisible by 15. 15 ones are 15, 7, 7 1, 15 4s are 60. See that. See, 11 is there.
So irrespective of the sign, we have to just add what the.
Only multiplication, that is.
So you are multiplying the remainder or adding the remainder, sir?
No, if there is a, see, you can do either way only. If the divisor is, if the number is,
13 into 11, 13 into 17 into 12 into 18 into 12.
Sir, one ನಿಮಿಷ ಇದೆ ಸರ್. ಇವಾಗ -2 + 2 ಇದೆ ಸರ್. ಅದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ -4 ಬಂತ, ಆಡ್ ಮಾಡಿ -4 ಬಂತ.
no, multiply. Because multiplication. Yes, only multiplication. Only the multiplication order. Yes.
13 into
13 into
17 into 12 into 18 into 12 by 15 into 12 by 15.
Right. So what happens now, we can say this is a -2 plus 2 minus 3 plus 3 minus 3. Okay. And 2 into 2, 4. 4 into 3, 12. 12 into 3, 36. 36 into 3, 108. 108 by 15. Or I think it's much bigger than what you can do. 2 into 4 into 3, 12. 12 into 3, 36. You can cut it off. 36 by 15.
It's a negative.
Hey, let it be. First we multiply. 4, 12, 36. 36 by 15. 6. 6 into 3, 18. You can take 18. Again 18 by 15, 3. Now we can see minus into plus, minus. Minus into minus, plus. Plus into plus, plus. Plus it, this is a minus 3. It means 15 minus 3. 12. Just like that. Because if we go to 36 into 3, again consumes more time.
Sir, on the travel solution.
And here you can take like 4 into 8 into 6 by let us take 5 small. What is the remainder? What is the remainder? In the upcoming days, I will give some more questions on this topic.
2 is the remainder.
2 is the remainder. Okay. Now we can take -1. This is plus 3 plus 1. 3 into 1, 3. Yes. Minus 3. It means 5 minus 3 is what? 2 is the remainder. Or you can check, cross check. 4 into 8, 32. 32 into 6. 32. Which one?
13 into 17 into 12.
Line come. 4 into 32. 32 into 6 what? 32 into 6. 192. 192 by 5. 4, 2. See that 2. Right. Yes.
Remainder 3.
Remainder 3, na? This is a 13 by -2 plus 2 minus 3 plus 3 minus 3. 2 to 4, 4 3s are 12. 12 into 36. Okay. Even 36 into 3, what happens? 36 into 3. 108. 108. What is a plus by 15? Alva? 15, 105. 3 it will come. And minus into plus minus, my plus minus 3. Minus 3 it will come. Signs you can take.
Okay, sir. Minus 3.
Minus 3 means that should be subtracted from the divisor. If there is a minus value, that should be subtracted from the divisor.
Sir, the answer is 3 only, sir. Sir, I'll tell you how, sir.
No, 3 only, but see that minus 3 it will come. Not just 3, it is a minus 3. No.
Minus, sir.
As of till it's okay?
Sir, minus into plus is minus.
Okay.
Minus into minus is
Plus.
plus in.
ಸರ್ ಇವಾಗ 108/15 ಏನು ರಿಮೈಂಡರ್ ಸಿಗುತ್ತೋ ಆ ಹೋಲ್ ನಂಬರ್ ಮಲ್ಟಿಪ್ಲೈ ಬೈ 15 ಅಷ್ಟೇ ಬಿಡಬೇಕಲ್ಲ ಸರ್?
ಹೌದು.
ಮತ್ತೆ ಅದು 3 ಬರುತ್ತಲ್ಲ.
But signs you can multiply, na?
Minus.
Plus or minus signs are there.
ಪ್ಲಸ್ ಸೈನ್ ಇದ್ರೆ 3 ನೇ ರಿಮೈಂಡರ್.
That's all. If there is a plus sign,
ದೆನ್ 3 is
then 3 is itself is a remainder.
But now minus will come, sir.
If minus comes means that should be subtracted from the divisor.
That we will do. But he's telling the remainder is 3.
Now it's okay. No, this confusion.
Why is it the answer?
ಅದು ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬರುತ್ತಲ್ಲ ಫೈನಲ್ ಆನ್ಸರ್. ಸೊ ಅವಾಗ ಡಿವೈಸರ್ ಇಂದ ಇದು ಮಾಡಬೇಕು.
ಆಮೇಲೆ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು.
ಇವಾಗ 3 ಬೇಕು. ಇದು ನೆಗೆಟಿವ್ ಮೈನಸ್ 3 ಬರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಡಿವೈಸರ್ ಇಂದ ಇದನ್ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ಪ್ಲಸ್ 3 ಇತ್ತಂದ್ರೆ
3 ಅಂದ್ರೆ
ಅದೇ ಕನ್ಫ್ಯೂಸ್ ಆಗಿತ್ತು. ಪ್ಲಸ್ 3 ಇತ್ತು ಅಂದ್ರೆ
That itself is the answer.
ಮೈನಸ್ 3 ಇತ್ತಂದ್ರೆ ಡಿವೈಸರ್ ಇಂದ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು.
Yes, that should be subtracted from the divisor. That's okay. Like that you can take. Okay. Even I will give more problems related to the remainder rule. I will write and give you. You can solve it. Okay, that is the thing. That is okay. Yeah. Shall we close it now? No, I think it's 12:05. Any other doubts you can ask me tomorrow. That is.
Sir, 108/15 is there, sir.
Yes.
That you can divide by minus 3.
Yes, because the 108. See.